All right, Intermediate Algebra Homework 30, still working with factoring. Now this is going to combine factoring out your greatest common factor and then factoring your quadratic expression that you get when you have a squared term. So it tells me to factor completely. When it says factor completely, that's a hint to look for your greatest common factor first. There's something I can divide out of all three terms. 9, 24, and 12 are all divisible by 3. I have an x to the 5th, an x to the 4th, and an x to the 3rd. I can do the lowest one, so x to the 3rd. So 3x to the 3rd is my greatest common factor. I'm then going to divide that out of each term. 9 divided by 3 is 3. I subtract my exponents. 5 minus 3 is 2, so I get 3x squared. Plus 24 divided by 3 is 8. 4 minus 3 gives me 1, so I get 8x. 12 divided by 3 is 4. 3 minus 3 is 0, so I don't have any x's on the end. So once I've factored out my greatest common factor, I'm left with a quadratic expression, the ones with the squareds that came from foiling something out. This is still going to be in front, 3x cubed. I'm going to try to factor this. Now this doesn't factor every time. Sometimes this is my answer, but most of the time I'm going to be able to factor it a second time. And so I got to check. Factors of 3x squared. 3x times x. Since both of these are pluses, we have a plus and a plus. Factors of 4. I could either use 1 times 4 or 2 times 2. Let's see, if I do the 2 and the 2, my outside product is 6x, my inside product is 2x, and sure enough, 6x plus 2x gives me the 8x in the middle. So this is going to be my answer. So the second one there. Factor completely. I'm going to start by taking out my greatest common factor. 9, 33, and 30 again are all divisible by 3. I have v to the 7th, v to the 6th, and v to the 5th. I use the lowest one, v to the 5th. 9v to the 7th divided by 3v to the 5th. 9 divided by 3 is 3, and then 7 minus 5 gives me v squared. Negative 33 divided by 3 is minus 11. 6 minus 5 gives me v to the 1st. 30 divided by 3 is 10. 5 minus 5 is 0, so I don't have any v's left. I have a quadratic expression. It may or may not factor again, but I've got to check to see if it does. Factors of 3v squared, 3v, and v. The end is a positive. If the end is a positive, both signs are the same as the middle, negative and a negative. Factors of 10. 1 and 10 or 2 and 5, probably the 2 and the 5. I probably don't want to do 3 times 5 because that's already 15. So I'm going to try my 5 here and my 2 here. My outside product is negative 6v. My inside product is negative 5v. Sure enough, negative 6 plus negative 5 is the negative 11 in the middle. And so I've got it factored correctly. Third one, same kind of thing. Tells me to factor completely. I look for my greatest common factor. I have 4, 18, and 10. All of those are divisible by 2. U to the 5th, U to the 4th, and U to the 3rd. So I'm going to use the U to the 3rd since that's my lower exponent. 4u to the 5th divided by 2u to the 3rd would be 2u to the 2nd. Minus 18u to the 4th divided by 2u to the 3rd is minus 9u. And negative 10u to the 3rd divided by 2u to the 3rd is minus 5. So again, we want to try to factor it again. Sometimes it won't. Most of the time it will. Factors of 2u squared. 2u and u. My signs. The end is negative. I know I have 1 plus and 1 minus. I don't know what order. I'm just going to guess. Factors of 5. 1 and 5 is the only way I'm going to get 5. So 2 times 5. So 2 times negative 5 would be negative 10. Negative 10 plus the 1u in the middle, sure enough, adds up to the negative 9. So matter of guessing and checking till you find the outside plus the inside products that add up to the middle. So 2u to the third times 2u plus 1 times u minus 5 would be my answer. The next one says factoring with the repeated use of difference of squares. Notice again the directions say factor completely. Whenever it says factor completely, it gives me a hint, look for a greatest common factor. 32 and 2 are both divisible by 2. I've got a u squared and a u squared, so I can take out the u squared. They both have that in common. I'm going to divide that out. So 32 divided by 2 is 16. 2 minus 2 leaves me 0 u's. Minus, here I'm going to take out the 2u squared, leaves me just the 4v to, the v to the fourth, excuse me, the v to the fourth. So the 2 would cancel out, the u squared would cancel out, I get the v to the fourth. Now what should happen is I should get the difference of squares. 16 is a perfect square, v to the fourth is a perfect square. I'm going to factor the difference of squares from FOILing. Factors of 16, 4 and 4. This is a negative, I have a plus and a minus. I want the factors of v to the fourth. V to the fourth would be v squared and v squared because I add my exponents. 2 plus 2 is 4. We get a minus 4v squared and a positive 4v squared, which is the 0 v squareds in the middle, and that's how come that factors. Now we want to keep going because it says we're going to do repeated use of my difference of squares. Now if I try to factor 4 plus v squared, 4 plus v squared, I would say 2 and 2, a plus and a plus, and a v and a v. But if I FOIL that out, I'm going to get 2v plus 2v, which is 4v. I don't have a 4v in the middle. If I have the sum of perfect squares, I can't factor it. There's no way to make it work because I'm always going to get that middle term. So I can't do anything with the one with the plus sign. But the one with the minus sign is the difference of squares again. That one's going to factor a second time. So 2u squared, 4 plus v squared, and then I'm going to have my 2 sets of parentheses. Factors of 4, 2 and 2. Since this is a negative, a plus and a minus, factors of v squared, v and v. Again, you get a negative 2v and a positive 2v, and the 0 then comes up to the middle, and the difference of squares is factored. So they call this the repeated use of difference of squares because I factor it once, and then I end up factoring it a second time using my difference of squares formula. Number 5, again it says factor completely. Look for my greatest common factor. I've got a 2 and an x to the third in both of them. That makes it easy. Taking out the 2 and the x cubed, I get u to the fourth. Minus, here I have to be careful. Think about when you do 2 divided by 2. 2x cubed divided by 2x cubed is 1. There is a number there. It's not a 0. It's a 1. Anything divided by itself is 1. So that if I multiplied it back out, I would get that number. Again, we should get the difference of squares. We do. So we have the 2x cubed. We're going to factor this. Factors of u to the fourth, u to the second, and u to the second. Since this is a negative, one's a plus and one's a minus, factors of 1. Well, there's only way to factor 1. 1 times 1. Again, there's no way you can factor the sum of squares. Will not work as hard as you may try, but we are going to factor that difference of squares a second time. So 2x to the third times u squared plus 1, and then repeating the difference of squares formula. Factors of u squared, u and u. My signs, a plus and a minus. Factors of 1, 1 times 1. So all of that is going to go in for your answer. 2x to the third times u squared plus 1 times u plus 1 times u minus 1. Number 6 is going to be the same kind of thing. Again, it starts out and says factor completely. So in this case, I don't have a number in common because I have an 81 and a 1 that's not written there. But they both have an x to the third in common. So x cubed comes out. If I take the x cubed out of both of those, I get 81 minus u to the fourth. Again, 81 is a perfect square. I've got the difference of squares again. So I'm going to factor. What times what is 81? 9 times 9. A plus and a minus factors a u to the fourth. U to the second and u to the second. Again, looking at that, the sum of squares will not factor, but the difference of squares factors a second time. So factoring my difference of squares, factors of 9, 3 times 3, I have a plus and a minus, factors of u squared, u and u. All of that goes in for my answer. X to the third times 9 plus u squared times 3 plus u times 3 minus u. Now, the next one is factoring the sum or difference of cubes. I strongly recommend that you go under the resources on Alex and find E49 and print out my explanation. I'll explain it as I go here, but if you just have the note sheets with my notes on them, probably is going to make this factoring easier. When you factor the sum or the difference of cubes, it'll factor both with a plus and with a minus, unlike squares. You're going to have one set of parentheses that has 2 terms. The other set of parentheses is going to have 3 terms. So I have one small one and one big one. I am first going to start out and do the cubed roots with the same sign. So, thinking about the cubed root of 27u to the third. The cubed root of 27 is 3. The cubed root of u to the third is u. If you happen to do 3u times 3u times 3u, you get 27u to the third. Plus the cubed root of 125. Cubed root of 125 is 5, because 5 times 5 times 5 is 125. So, first set of parentheses, I just take the cubed roots of each of my terms. Now, I am going to do the squares of these numbers here. So, the first one is the square of the first one. If I take 3u and 3u, I get 9u to the second power. Right? 3u and 3u is 9u squared. So that you should be able to take 3u times 9u squared, get 27u to the third. I'm going to square the 5. 5 squared, 25. That should always have a plus sign in front of it, because if I square something, it's always positive. Right? Even a negative times a negative gives me a positive. So that if I take positive 5 times a positive 25, I get a positive 125. Now the middle term is what cancels everything out when I multiply. This value here in the middle is going to be the opposite of the product. My product would be 3u times 5. 3u times 5 is 15u. This is a positive, so this is going to be a negative. That crazy looking thing is going to be my answer. If I wanted to check it, I could multiply it out. 3u times 9u squared is 27u to the third. 3u times negative 15u would be negative 45u. 3u times 25 would be positive 75. Oops, that's supposed to be negative 45u squared. I had a u and a u squared. 3u times 25 is positive 75u. Doing my 5. 5 times 9u is positive 45u squared. Right? 5 times 9u squared, 45u squared. 5 times negative 15u. 5 times negative 15 would be negative 75u. 5 times 25, positive 125. Notice when I multiplied those out, these are opposite, these are opposite. So I just get the 27u cubed plus the 125 when I FOIL that all the way out. So, applying my difference of squares formula to the difference of cubes formula to the next problem. Factoring, these are both perfect cubes. So I've got one with 2, one with 3. The cubed root of 64y cubed. Cubed root of 64 is 4, so I'm going to have 4y. 4y times 4y times 4y is 64y to the third. Same sign, cubed root of 27. Cubed root of 27, just a 3. 3 times 3 times 3 is 27. Going to the next part, I want to do the squares of each of my first and my last. So if I square 4y, 4y times 4y is 16y to the second power. 4y times 16y squared should be 64y to the third. Squaring my negative 3. Negative 3 times negative 3, positive 9. Negative 3 times a positive 9 is the negative 27. The middle term, the opposite of this product. This product would be negative 12y. So in here, we're going to have a positive 12y. I'll smush it in because I didn't give myself enough writing room. So the opposite of this product is what your middle term is. I'm going to move the board. Hopefully you wrote down some notes or printed out my note sheet from the resources. So number 9, I'm going to factor those cubes. I've got one with 2 terms, one with 3 terms. Cubed root of 125. Cubed root of 125 is 5. 5 times 5 times 5 is 125. Same sign, so bias. Cubed root of 8v cubed. Cubed root of 8 is 2, so I'm going to have 2v. 2v times 2v times 2v is 8v to the third. Squaring each of them, 5 times 5 is 25. 5 times 25 is 125. Squaring my negative 2v. Negative 2v times another negative 2v is a positive 4v squared. Negative 2v times 4v squared is negative 8v to the third. My middle term, the opposite of the product of these two things. 5 times negative 2v is negative 10v, so this is going to be positive 10v. And that's going to be my answer. Again, if you're really not sure, multiply it out, check to see if it works. It should. The next ones. Solving an equation in factored form. So, solve if there's more than one solution, separate them with commas. In fact, for every variable we should have a solution. In this case, we have 2 different variables. If I have something written in factored form and it is equal to 0, either this factor could be 0 or this factor could be 0, because 0 times anything is still 0. So all we're going to do is break this into 2 really easy problems. Either the 5y plus 4 could equal 0, or the 1 plus y could equal 0. So solving this first one, I'm going to minus my 4, 5y equals negative 4, and divide by 5. Y equals negative 4/5. On the next one, I'm going to move my 1 to the other side, so I'm going to minus 1, y equals negative 1. So, just because checking with this one's easier, look at it this way. 5 times negative 1 is negative 5. Negative 5 plus 4 is negative 1. 1 plus a negative 1 is 0. If I take negative 1 times 0, guess what I get? I get 0. On the other one, I would maybe use my calculator because I have a fraction. 5 times negative 4/5 plus 4, however, the 5's cancel out. Negative 4 plus 4 is 0. So that factors 0. 1 plus a negative 4/5 would be a 1/5, and 0 times 1/5, sure enough, is 0. So my answers is that y could be -4/5 or -1, and I'm going to put both answers in and separate it with comma. Number 11, we're going to solve separating with commas. So normally I would say -2 equals 0, but there's no variable there. -2 can't equal 0. Can't solve that. This one, however, has a variable. 4w minus 6 equals 0, or 1 minus w equals 0. And I'm going to solve each of those. So here, solving this, I would add my 6. So 4w equals 6. I have to divide by 4. 6/4 I can reduce down. So 3/2 would be my answer. On the other one, you could minus the 1 first, but then you end up having to divide. If you happen to recognize on this one that it's easier to move the w than move the number, it's a shortcut for you. If not, it's still going to give you the same answer. I'm going to go ahead and just add my w to make my w positive, so 1 is equal to w, and I already have it solved. Otherwise, if you minus 1 and divide by -1, negative divided by a negative gives you a positive, and I get the same answer. But just a little shortcut there. If you have the minus w, move the w instead of moving the number. Going to make your solving a little quicker. Number 12, same kind of thing. Once I find number 12, we want to solve. Now look at this one. This one does have an x with that, so I do have to set that equal to 0. I'm going to have 1, 2, 3 answers because there's 3 x's in my problem. So 5x could equal 0, x minus 6 could equal 0, or 4 minus 3x could equal 0. So on the first one, I'm going to divide by 5. 0 divided by anything, still 0. This one, I'm going to add my 6, so x equals 6. This one again, you could move the 4 first and divide by -3. If you happen to recognize this as negative, you might want to just move the x over. That makes that positive 3x. 4 equals 3x, and when I divide by 3, 4/3 is my answer. And I'm writing 4x. And so I have 3 answers, x equals 0, 6, or 4/3. All 3 of them will go in on Alex. Now the reason that we solve by factoring is because sometimes we have quadratic equations. Quadratic equations just mean you have the squared term. When I have a quadratic equation that's in correct order, meaning descending order, the squared, then the u, then the constant term, the number, and it's set equal to 0, I can factor it out, so I have a problem that looks sort of like this. So, whenever I have a squared term in my problem, I need to make sure it's in the right order. I'm then going to solve by factoring and making sure it's set equal to 0. So u and u. The end is positive. That means both signs are the same as the middle, negative and a negative. Factors of 21 that give me 10 in the middle. Well, 3 times 7. Checking my outside product plus my inside product. -7u plus a -3u, sure enough adds up to -10u. So I've got it factored correctly. I now set each of these equal to 0. u minus 3 could equal 0, or u minus 7 could equal 0. Solving these, we just have to move our number over. So I'm going to add 3, u would equal 3. I'm going to add 7, so u could equal 7. Checking that out, what does that mean? It means that these are the only 2 numbers you could ever plug into this equation and get an answer of 0. If I pick the 3, 3 squared minus 10 times 3 plus 21. 3 squared is 9. Negative 10 times 3 is minus 30 plus 21. If you do 9 minus 30 plus 21, sure enough you get 0. If I check the 7 out, 7 squared minus 10 times 7 plus 21. 7 squared, 49. Negative 10 times 7 is minus 70 plus 21. If you do 49 minus 70 plus 21, you get an answer of 0. Any other number you pick and try to substitute in, you will not get an answer of 0. 3 and 7 are the only ones that will give you that answer of 0. Number 14, same thing. I'm solving it for v. I have a quadratic expression. It is set equal to 0. So I know I can solve it by factoring. Factors of v squared, v and v. My signs. If the end is a positive, both are the same as the middle, a plus and a plus. Factors of 12 that give me the 8. Well, 12 is 1 times 12, 2 times 6, or 3 times 4. The pair that's going to give me 8, got to be the 2 and the 6. 6v on the outside plus 2v on the inside. 6v plus 2v is 8v. It's a typo, I better fix that. It's supposed to be a v instead of a u. Solving these, v plus 2 equals 0 and v plus 6 equals 0. All I have to do is move my number to the other side, which is going to give us the opposite number. So minus 2 and minus 6. So v equals negative 2 or negative 6. I better fix that typo so that next time these get printed out, you guys got the right answers, the right problems. There we go. One last one, solving for y. Again, we have the quadratic expression. It's set equal to 0. I'm going to solve by factoring it out. Factors of y squared, y times y. My signs, since the end is a negative, I've got one of each. A positive times a negative is a negative. I want the factors of 30 that will give me 1. 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6. Since these are opposite, I'm really going to subtract or adding opposites. I want the pair that's going to give me a positive 1. That means my bigger number has to be the positive number. 6 minus 5. Negative 5y plus 6y is a plus 1y in the middle. So if y plus 6 equals 0 and y minus 5 equals 0, I'm just going to move my numbers, which gives me the opposite signs. Negative 6 here, positive 5 here. Y equals negative 6 or 5 for my two values that would give me 0. So whenever we work with a quadratic expression, we want it equal to 0, and we can solve it then by factoring, provided it factors. And that is the end of homework day 30.